All right, I would like to thank everyone for taking the time to attend today. My name is Lance Zurich, and today we are going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, both of these sets are designed for conducting a project-based class, and that's where students will be required to design and build a series of original prototypes based upon their own research and activities. And each set includes standards-focused curriculum created especially for Studica by noted educator and STEM expert, Tom White. So today we're going to start off where so many technology-focused presentations for education start these days, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or the need for better STEM education in the schools, STEM, of course, being the acronym which stands for science, technology, engineering, and mathematics, what they're essentially talking about when they say this is they're talking about the urgent need to prepare our students with the background they need to successfully compete in the job market that they're going to graduate into. See, in the employment market that once greeted our grandparents or even perhaps our parents, a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now students must be prepared to enter a world that is increasingly focused on programming, automation, IoT, and rapid advances in all aspects of technology. Now, in short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. This, of course, is why so much of the emphasis in education over the last decade has been on developing STEM skills. Now, every new advantage we enjoy, and this can be things like the tablets and smartphones that we all use daily, every one of these things was created because of individuals who helped to make those advances. Countries all around the globe, countries like China and India and so many others, are making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. Now, here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also to be part of the next wave of advancements we rely on to stay competitive on the world stage and to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM education and technology-focused programs, let's now instead move right along to the main topic, which is, of course, mechatronics. Now, mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. Well, just how prized? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they need to start developing the habits and the career focus as early on as possible, in high school, if not even in middle school. Now, the dilemma for educators, whether in the classroom or the homeschool environment, is, of course, finding ways of introducing this kind of subject matter to students in a way that gets them interested and involved in the learning process, and not just memorizing obscure facts or ideas just to regurgitate them for a few tests, then promptly flush them from their memory. No, to best help students to be successful and to really encourage them to consider pursuing further education in subject matter such as this, educators need to be able to present the material in a way that makes it relevant. And that means answering the eternal student question, well, why do we need to know this? And it also needs to be engaging in a way that holds students' attention better than rote notebooks and lecture presentations, and something that has visible real-world applications in which the students can get involved in doing things hands-on. Now, it's with this dilemma in mind that we created the Studica Mechatronics programs. These two special sets, one designed as an introduction to the world of mechatronics, and one of which is intended to be essentially a standalone class dedicated to the subject, these sets were created to provide all of the materials in one place that educators will need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, and which is crafted to meet current academic standards. Each of the two Studica Mechatronics program sets has its own detailed day-by-day curriculum document, which again was created especially for Studica by noted educator and STEM expert Tom White. The curriculum comes as a downloadable PDF, which is available for free with the purchase of each set in whatever quantity you purchase. Now, this curriculum is designed to align with the most widely accepted academic standards currently in place in the United States. The curriculum is also designed for offering a project-based learning program, and this means that solving the problems that arise in each unit requires the student to be actively involved in the research, involved in the design, and the trial and error experimentation and all the activities leading up to, as well as the building of actual working prototypes that will provide the required answers. And students don't do this alone. They'll be asked to work in small groups or teams of 4 students each. This will help to develop the soft skills that students also need as much as they need the technological skills, maybe just as, very important. And by this, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some very affordable programming software, each of these sets includes all of the physical building materials each of these groups will need to enable it to address all of the design projects presented throughout the course of the entire curriculum. Now, the curriculum is designed to enable teachers of all sorts of backgrounds, even teachers from non-science or technology-focused disciplines, to allow all these teachers to have the information they need at hand to properly prepare them for conducting the activities and to increase their comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap both for students and for the teachers. Various supplemental materials are included as well, both in link form throughout the curriculum and also at the end of each of the units. There are also special tutorials on familiarizing students with the building system they will use to address the projects presented in each of these units. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging real-world style scenario, where students must work together in small teams, again, teams of 4 students per group, and they're going to work together to create a solution to these problems. The project units each contain embedded academics, and at the end of each of these units, students will be required to make a formal presentation of the prototype they have created to address the unit's real-world scenario and to explain and justify their reasoning. There is a technical literacy task driven by each of these projects. As they work to address each project, students will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. Again, as required by each project, students will be asked to create original prototypes and any required programming-based solutions, and also, again, to maintain detailed documentation during the entire process. Now, as I mentioned a few times in this presentation, the curriculum that accompanies each of the Mechatronic Program sets was created especially for Studica by a man named Tom White. You see Tom right here. Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs for educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards currently in place in the United States. These include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and standards for technological literacy. Now, as I mentioned earlier, the programs are designed to be project-based. Now, this approach helps to answer those eternal questions like, why do we need to do this? And where will we ever use this? That too often can arise when students are presented with technical subjects that might seem abstract in their purpose. Here, instead, they can see firsthand why these things are necessary and where they are useful. The concept of working in the small groups to help solve the project problems also helps students to develop the high demand skills that employers look for, as we talked about before. Skills like communication, analytical skills, quantitative skills, flexibility, adaptability, and problem solving. Now, in this project-based format, subjects are integrated. And what by that we mean the math is reading and the writing and so on. And this is really ideal for STEM education. And also because the manner in which students must approach each of these projects with the research, the testing, and the group give and take, just to provide a few examples, it allows for a much deeper exploration of problems than traditional teaching methods might allow. Now, the projects presented in each of these units are also designed so that if you have several groups working on the same project, you should see variations in on the various prototypes and solutions that each of the groups will design. Now, this can be because of creativity or differences in the research and the approaches taken by each group, but in any case, students can see firsthand that problems can have many different answers and that often there is not only one right answer. Each project in the curriculum presents students with the opportunity to plan, organize, and conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects, research that is utilized in the design, utilized in the prototyping, the testing, the evaluation, and redesign phases of each of these solutions. And again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. The team approach, as stated before, helps promote soft skills, things such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. Just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And again, everything you need to conduct the program, with the exception of the programming software, which can be purchased in either single user licenses or, probably more likely, affordable school site licenses, everything else is included inside of each box. Access to the free curriculum download is included with the purchase of each set. Once again, whether you buy 1 set or however many, you get access to the curriculum. And also included are all of the building materials which students will use in the creation of each of these prototypes. Now, these building materials are from the unique Fisher Technic building system, and among the components included in each set are 2 robotic controllers and 2 power supplies. Now, that could bring up the question for those of you who aren't familiar with it, so let me tell you a little bit about Fisher Technic. Fisher Technic is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed to simply stack, Fisher Technic was created with more of an engineering mindset. By that I mean that the core building block in the Fisher Technic system is unique in that it allows attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together and lock in place. Hundreds of different parts available will also help you to address very specific design needs. Fisher Technic, just to continue, was created back in the 1960s by German inventor Arthur Fisher, who was noted for countless innovations used in the construction and the automotive industries. Mr. Fisher, at the time of his death in 2016, held more patents in his name at that time than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher Technic, Mr. Fisher was also the inventor of synchronized flash photography back in 1949, and he was also the creator of the expanding nylon wall plug, which a lot of people are, of course, going to be familiar with, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as components used in automobile manufacturing. And it's also well known for providing consulting services related to automated processes. Now, with all of that being said, let's begin looking at each of the two individual sets. And we're going to start off with the Studica Introduction to Mechatronics Program set, or for those of you who like acronyms, you can refer to it as SIMP. Now, this set is designed to help provide a well-rounded, comprehensive introduction to the core concepts of mechatronics. Each set includes access, as I've mentioned, to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, of course, written by Tom White. Now, the curriculum contains enough activity material to fill approximately 45 academic hours. As such, we recommend this set for insertion into regular related class activities, as a short class unto itself, for after-school program use, or of course, for homeschool use. The curriculum created for this set is standards focused, again, using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. The set is designed for use in middle school or high school classes, or again for addressing the grade levels in a homeschool environment. Each set contains a collection of over 700 Fisher Technic building components, and this will include everything from gears, wheels, axles, blocks, sensors, and a lot more, as well as, again, 2 robotic controllers and 2 power supplies. The robotic control software is required and is sold separately, as I mentioned before, and we'll discuss that in a little bit. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 different project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, conversion and storage of energy, and an introduction to control systems. And there are also activities included to address the following areas that come up during the course of the curriculum: sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using the software and the robotic controllers, sensors like the digital switch and the digital photo transistor, working with open loop and closed loop programming as well as digital branching, working with analog sensors such as the photocell LDR, working with analog branching, analog sensors like the NTC resistor and the potentiometer. Now, before we go any further into the structure of the curriculum, let's first look at what is covered in the second set. Now, this set is the Studica Teaching Applications of Mechatronics Program. The acronym, for those who like such things, for this set is STAMP. The set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. The set includes access to the free downloadable 401-page curriculum document, in this case entitled Mechatronic Applications by Tom White. And the activity materials in this curriculum document, when used in conjunction with the contents of this set, is designed to fill approximately 180 academic hours. Essentially, this set can be seen as a more expansive version of the material touched on in the previous set, and is designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent, each week for a full academic school year. Again, this set is designed for offering students a standards-focused, project-based learning experience, and is designed for use in middle schools, high schools, or for addressing similar grade levels in a homeschool setting. The materials in this set consist of a selection of over 1,200 Fisher Technic building components, and once again, this includes a wide array of gears, blocks, sensors, axles, and much more, as well as, again, 2 robotic controllers and 2 power supplies. And as I mentioned before, the programming software that is required is not included, and we'll talk about that. Now, there are twice as many project units included in the Studica Teaching Application of Mechatronics Program set as with the previously discussed set. And these include units on the following: sketching and documentation, simple machines, mechanical systems, basic electricity, and project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided for various activity materials for students to utilize. And these will include sections on the following: sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the software and the robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital phototransistor, working with closed loop programming and digital branching, logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, the potentiometer, and working with data. Now that we've had a look at how each of these sets differs and the specific subject matter covered by each of the sets, let's instead now look at exactly how the curriculum itself is structured. Now, both versions of the curriculum share the same format when it comes to the structure of each of the units presented in with the projects. And as already discussed, each version will include tutorial materials, each will include activity materials, standards, and supplementary materials. Now, in each case, the curriculum is also designed to be turnkey. And what we mean by that is that besides the elements I just mentioned, each unit is designed in such a way as to enable teachers from all types of backgrounds, and again, it doesn't matter if you're from a non-science background or non-technology focused background. Still, if you use the materials as we presented them here, you should be able to quickly become comfortable with delivering the material simply by reviewing each selection before you present it in class. Each unit includes the following sections: an introduction, the purpose of the project, the concepts to be explored, an outline, the standards to be addressed, assessment rubrics for the teacher, the essential question to be explored, a student scenario, which gives them a real world scenario, a daily plan to keep everyone on track, vocabulary words, and other resources. Now let's look at each of these sections a little more closely. Each unit starts with an introductory section and the purpose of the project. Now, just as you would likely gather from that name, this is the section that provides a brief description of the topic that will be explored in the coming days and activities. And this is also the section that seeks to clearly spell out to students that answer to the eternal question, why are we doing this? The next section focuses on the concepts to be addressed in the unit. And these can be thought of as the broad ideas that will be explored in the unit and the core information that students should take from this project that will be essential for them to understand and utilize not only today, but hopefully to draw upon as they move forward in STEM fields of study and, of course, we hope STEM-related careers. Now, following this, we get into the outline. In this section, we drill down more specifically to what will be addressed in the unit. Now, as the example shown on the screen now is taken from a unit that addresses aspects of programming, you will see that we touch upon areas such as the methods for writing programs, whether it be flow charts, word problems, etc. Program characteristics, things like open or closed loop, talking about things like branching, digital, analog, subprograms, and so on. Now, the next section of each project unit focuses on the specific academic standards which will be addressed in that unit. Now, again, as you can see, this includes college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for K-12, and the standards for technological literacy. Each project unit also contains rubrics, and this will include both rubrics for the specific project being covered, along with general rubrics for literacy tasks. Next up is the essential question. And this can be thought of as, again, as the big picture question of what will be focused on the smaller individual activities that the students are going to be doing. And of course, all the aspects of the larger project which students will be asked to complete in this section. Now, the student scenario is where the specifics of this project will be addressed, and they're finally all detailed here, all of which is presented in the context of a real-world style scenario where students are presented with a problem where they must work in groups to solve it together. Now, this problem will require students to design a unique and original answer to solve it, usually in the form of a working prototype, along with, again, whatever programming may be required. Now, if you look closely at the student scenario shown on the screen right now, you will see that the project in this particular unit has each group of students take on the role of a design team employed by a firm that manufactures garage door openers. Now, in this particular case, students will have to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are spelled out, and in this case, it's such things as the use of limit switches, meeting certain safety code requirements. For example, a method for sensing if anything is in the way of a closing door, so that's going to have to be addressed. And also the incorporation of an automatic light. Now, as discussed previously, each group of students will be tasked with creating both a unique and original prototype, and in this case, it's a garage door opening system. And along with this, they also have to create the programming needed to control this prototype. Now, along the way, they will be required again to document the entire process in both the design notebook and a digital engineering journal. And they have to notate all of the research, all of the trial and error experiments. They have to keep copies of all the design sketches and any revisions and so on. So a lot of documentation here. And at the end of each project unit, each group of students will be required to make a formal presentation in front of a class, during which they demonstrate their prototype and programming in action, much as they would be required to do for an actual employer or a client in the real world. Next up is the daily plan. And this is the section that spells out clearly, both for the students and the teachers, what will be expected of the students, how the teacher will conduct the day's classroom activities, and what specific subject matter will be covered. Now, some days may involve discussions. Other days may involve research or building smaller projects that help provide the building blocks students will draw on to complete their larger projects, as described in the student scenario. But in short, you can think of the daily plan basically as a roadmap for everyone. Now, you will see too that along the way, as different aspects are addressed in each day's activities, such as, for example, what is required in a design notebook, or how to use the control software, or working with the controller, or working with flowcharts, or what have you, that as each of these things are encountered, there are also links to sections that will provide further instructions and information on exactly how to go about doing that. And again, at the end of each of these units, after the daily plan, is a section containing vocabulary. And these are basically important words and important terminology that are introduced during the project unit. And there's also a selection of important resource materials that are included. Now, these resources can contain a mix of different types of material depending on which unit you're looking at. And this can include anything from carefully vetted websites and internet-based links and video links. It could include PDF documents or PowerPoints or what have you. And besides the project units, each version of the curriculum also includes a section devoted to learning exactly how to use the Fisher-Technic building system. Now, this includes information on how the parts fit together using the pin and groove assembly method. It includes a section on identifying the various types of parts, from the different types of girders and blocks to the various axles, gears, rivets, and other pieces that are part of this set. And it also gets students to build a basic sample model to help familiarize them with the system before they move on to the larger projects described in each of the units. And as learning about and maintaining proper documentation is one of the areas really stressed in the course of the curriculum, there is a section which details just what defines each type of documentation listed on the screen now: the design process, the engineering notebook, design documentation, so on. And it tells students exactly what is required for each of these. And as the process of conducting a project-based class might be something that some teachers might not be familiar with. It's a little less structured than your normal classroom activities might have been. Well, for teachers such as that who may want a little more guidance on this, there's a section that discusses specifically project-based STEM education and its benefits. So at this point, let's just review each set again briefly, but this time with pricing. First, we have the Studica Introduction to Mechatronics Program set, and this is designed as a standards-focused, project-based introduction to the core concepts of mechatronics. The program is conducted with the use of a highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, again written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the materials in this set, will provide educators with enough activity material to fill approximately 45 academic hours. Again, it's designed for those educators who wish to offer short classes, after-school programs, insert it into other class activities, or to use it for homeschool use. The standards-based material is designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these specific grade levels. The physical materials in each of these sets includes a selection of over 700 components from the Fisher Technic building system, and this again includes everything from the sensors, the blocks and gears, and so much more that are going to be used to construct the prototypes required in each project unit of the curriculum, as well as 2 robotic control units and 2 power supplies. Software again is required for the use of these controllers, and we'll talk about that in just a second, I promise, finally. Again, each set is designed for use by a group of 4 students, with pricing starting at just $699 for a single set, and classroom size quotes for 20 students and above are available upon request. The other set is again the Studica Teaching Applications of Mechatronics Program set, and this is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics. This program is based around a highly detailed 401-page curriculum document entitled Mechatronics Applications, again written by noted educator and STEM expert Tom White. This document, like the one for the previous set, is a downloadable PDF document which can be accessed with the instructions included inside of each box. When used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity materials to fill approximately 180 academic hours. Again, this is designed for those educators and homeschoolers who are willing and able to offer a daily dedicated class period of 50 minutes per day, 5 or the equivalent, on this subject for a full academic school year. Of course, you could also break it up over 2 years if you wanted to, but if you're going to do it in one, you definitely want to have that at least 50-minute a day period. Again, the standards-based material is designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these specific grade levels. Each box contains an assortment of, in this case, over 1,200 components from the Fisher Technic building system, again including blocks, girders, gears, sensors, axles, and a whole lot more, as well as 2 robotic control units and 2 power supplies. Software, again, is not included. We're talking about it in a second. And once again, each of these sets is designed to provide enough materials for 4 students, with pricing for a single set starting at just $799 for a single set. And of course, classroom size pricing for over 20 students is available by quote upon request. And as I've mentioned several times that software is required, let me address that as well. The software in question that's used with these sets is the Fisher Technic RoboPro software, which is graphic programming software. By this, we mean that it uses a flowchart style design, which uses various icons, which students are asked to arrange and link to create the programs that are used to control each of these models. Now, graphic programming software is ideal for teaching the fundamentals of programming to users of all levels, and it helps to familiarize everybody with the basic skills, and it teaches the fundamentals that are used in all sorts of programming. Pricing for a single user license is only $36 per license, and an unlimited single site school license, which means that you can have unlimited users at a single site or building with this license. So you could use 1 computer with this, you could use 100, you could use 1,000, as long as they're at a single site. The cost for this license is only $120 per site license. And I also want to mention, please note that these are not subscription prices, these are not annual prices, These are basically non-expiring licenses that you can access as long as you have the software disk, which comes with each of these, licenses, and as long as you're able to install this on a compatible Windows-based desktop or laptop computer using Windows version 7, 8, or 10. So on that note, if anyone has any questions, this would be the time to use either the chat window, which you can type your questions in, or you can use the question and answer window, which is of course a little more appropriate, but you can use either. I will look at both. So if anyone has any questions, feel free to type them in now. I'll give you a second. I'll stop talking. I'll grab some water. I will go a 1. I will go a 2. If I don't see anyone start to type, I will move on to the next slide. Of course, you can still type even if I move on to the next slide. All right. If you're ready to take the next step, and that could be, let's say, if you want to request a quote, if you wanted to speak with your dedicated educational representative, or if you wanted to speak with me, you can call us here. Our number in the US, toll free, is Studica at 888-561-7521. If you want to email to get a quote for whatever school or district you might be in, you can email us at info@studica.com. If you have any questions for me specifically about anything that I mentioned during the course of the presentation, or if you're interested in knowing more about the Fisher Technic system, which I've talked about during this, you can also email me directly. And my email, as you see up there, is lance.zurek. So that's lance.zurek@studica.com. So on that note, I would like to thank you all for taking the time to attend. I hope you have a great day. And once again, we look forward to hearing from you. So please, again, use those email addresses, info@studica.com or lance.zurek@studica.com. On that note, have a great day, and we look forward to seeing you soon.